Hello everyone. Now I am going to discuss about rational number, which is first chapter of class 8. First of all, we all have to know what is rational number. Rational number. A number which is in the form of P by Q, where P and Q are integers and Q does not equal to 0, is called a rational number. A number which is in the form of P by Q, where P and Q are integer. First of all, we all have to know that what is integers. A natural number, 0 and negative of natural number is called integers. So here P and Q are integers and Q does not equal to 0 is called a rational number. As example, 1 by 2, 3 by 5, minus 1 by 2, 5, 6, 0, etc. Here 5, 6, 0 is a rational number because on denominator here 1 is common. Second, lowest form of rational number. A rational number P by Q is said to be in lowest form if HCF of P and Q is 1. Lowest form of rational number. If we have to find the HCF of P and Q and it comes 1, then a rational number is said to be in its lowest form. Third, equality of rational number. Two rational numbers P by Q and R by S are equal if and only if P multiply S is equal to Q multiply R. Two rational numbers are said to be equal when P multiply S is equal to Q multiply R. Number 4, properties of addition of rational numbers. First, closure property. The sum of two rational numbers is also a rational number. Closure property, the sum of two rational numbers is also a rational number. When we add two rational numbers, the result is also a rational number. Second, commutativity. if a by b and c by d are two rational numbers, then a by b plus c by d is equal to c by d plus a by b. That means when we change the order of number, the result is also same. Third, associativity. If a by b, c by d and d by f are three rational numbers, then a by b plus c by d plus e by f is equal to a by b plus c by d plus e by f. Number 5, existence of additive identity, which is 0. The sum of any rational number and 0 is the rational number itself. So the rational number 0 is called the additive identity for the addition of rational numbers. Existence of the additive identity. The sum of any rational number and 0 is the rational number itself. If we add 0 in any rational number, then the result is the rational number itself. So the rational number 0 is called the additive identity for the addition of rational numbers. Existence of negative, which is also called additive inverse of a rational number. The additive inverse of rational number a by b is minus b by a. 0 is the additive inverse of itself. The additive inverse means negative of any rational number. So the additive inverse of rational number a by b is minus b by a, and 0 is the additive inverse of itself. As example, if you write additive inverse of 1 by 5, so it is a positive rational number, so we write minus 1 by 5. If we have additive inverse of minus 2 by 3, so we write minus 2 by 3. minus minus plus, so result is 2 by 3. Number 7, properties of multiplication of rational numbers. First, closure property. The multiplication of any two rational number is also a rational number. In closure property of addition, we have the addition of any two rational number is a rational number, and in properties of multiplication of rational number, in closure property, the multiplication of any two rational number is also a rational number. Second, commutativity. If a by b and c by d are two rational numbers, then a by b multiply c by d is equal to c by d multiply a by b. Third, associativity. If a by b, c by d and e by f are three rational numbers, then a by b multiply c by d multiply e by f is equal to a by b multiply c by d multiply e by f. Number 8, existence of multiplicative identity. If a by b is any rational number, then a by b multiply 1 equal to 1 multiply a by b is equal to a by b. Existence of multiplicative identity. If a by b is any rational number, that means if any rational number is multiplied by 1 is equal to the rational number itself. So 1 is called the multiplicative identity for rational numbers. Number 9, distributive distributivity of multiplication over addition. If a by b, c by d and e by f are any three rational numbers, then a by b multiply c by d plus e by f is equal to a by b multiply c by d plus a by b multiply e by f. Here a by b is multiplied by c by d and a by b is also multiplied by e by f. Number 10. Existence of multiplicative inverse. Or reciprocal of a rational number. The reciprocal of a or the multiplicative inverse of a rational number a by b is b by a. Existence or multiplicative inverse. The reciprocal or the multiplication inverse of a rational number a by b is b by a. So here which is numerator, it comes in the denominator, and which is denominator, it comes on the numerator of the given fraction. That's all. That is the whole theory of chapter 1, which is rational number. Now I shall start the first exercise 1.1 of rational number. Exercise 1.1, question number 1. First, we have to add minus 5 by 7 and 3 by 7. Firstly, we take LCM of both denominator. So LCM of 7 and 7 is 7. When we divide 7 by 7, the result is 1, and 1 is multiplied by minus 5. Then here comes minus 5 plus same thing happens there, and here comes 3. Minus 5 plus 3, that means 3 minus 5. So the result is minus 2 by 7. Question number 2 first. We have to add 3 by 4 and minus 5 by 8. 3 by 4 plus minus 5 by 8. LCM of 4 and 8 is 8. When 8 is divided by 4, the result is 2. And when 2 and 3 is multiplied, the result is 6. Minus when 8 is divided by 8, the result is 1. And 1 is multiplied by 5, the result is 5. 6 minus 5 is equal to 1 by 8. You have to solve all left questions. First, you have to add 8 by 9 and minus 11 by 6. First of all, 8 by 9 plus minus 11 by 6. LCM of 9 and 6. LCM of 9 and 6 is 18. Now we divide 18 by 9. The result is 2. And 8 2s are 16. Minus, when we divide 18 by 6, the result is 3. And 11 3s are 33. Now we subtract 33 from 16. So the result is minus 17 by 80. For first, minus 12 by 5 and 43 by 10. We take LCM of 5 and 10, which is 10. Now 5 2s are 10, minus 12, so 12 2s are 24, minus 24 plus 43. Now we subtract 24 from 43. Now we have to write the result as a mixed fraction. So we divide the numerator by denominator. 10 ones are 10. Remainder is 9. So what the quotient becomes, we write here. Denominator is written same, and what the remainder is written in numerator. That is your answer. Now we shall start exercise 1.2. First, verify commutativity of addition of rational numbers for each of the following pairs of rational numbers. Numbers is given minus 11 by 5 and 4 by 7. What your commutative rule is? By commutative rule, for addition is a by b plus c by d is equal to c by d plus a by b. For verifying commutativity, minus 11 by 5 plus 4 by 7, 4 by 7 plus minus 11 by 5. We take LCM of 5 and 7, which is 35. Now we divide 35 by 5. Result is 7, and 7 is multiplied by minus 11, so result is minus 77. Plus, when we divide 35 by 7, the result is 5, and when we multiply 5 and 4, the result is 20. 4 by 7 plus minus 11 by 5. Minus 77 plus 20. Minus 57 by 35. Here we take LCM of 7 and 5, which is 35. 7 5 is 35, 5 4 is 20. Minus 5 7 is 35, 11 7 is 77. Minus 57 by 35 is equal to minus 57 by 35. Very wide. That's all. Now you have to solve all problems of exercise 1.1 and 1.2. On our next video, we shall discuss on exercise 1.3, 1.4 and other chapters. Thank you.